Thank you for joining us in this webinar on accelerating the time from R&D to deployment. I will first talk about our vision on how we can actually accelerate this path. Then I will talk about the OpendTect machine learning solution. And finally, I will talk about how we are implementing this acceleration. I trust most people know this curve, which is called the Gartner hype cycle, which gives a curve on the expectation versus time of an innovation. Something triggers the innovation, and then we get into a phase of high expectation where a lot of things are happening. New technology is developed at a fast pace, and at some point there starts to get a bit of a deflation because people are learning that the expectations cannot quite be met by this new technology, and then we get through this trough of disillusionment finally into a phase of enlightenment where the actual technology that is still good is being deployed in an operational settings. Now this curve has been around for some time, and I think if we look at the curve for artificial intelligence / machine learning, then it is actually already that we are in the third cycle of this curve. Started off with Alan Turing's paper in the 1930s about the Turing machine, and it was mainly theoretical at the time. We saw the discovery of the biological neuron and the mathematical equivalent analog of it, the perceptron, and then suddenly in 1969 a paper by Minsky and Papert came out on a rather simple problem, the XOR problem, that could not be solved by a single perceptron, and that caused the first phase of disillusionment. Then in the 1980s and 1990s we had a new cycle, probably triggered by the invention of the backpropagation algorithm, and this was the phase when I joined the frenzy in the 90s. With the development of machine learning, perceptrons, radial basis functions, coherent networks. A lot of good technology was developed that is still being very useful in our industry today. Still it phased out a little bit, but then a new phase started with the publication by LeCun of the convolutional neural network. That was in 1998. But I think the actual acceleration of this phase happened a bit later, and that is where we are right now with the fantastic deep learning algorithms that we see developed all over the place, the UNets, the GANs, the ResNets, you name it. Where this is going, I'm still not 100% sure. At some point the expectations will flatten off, but whether we get into another disillusion trough or whether it will slowly pace off and continues at a slower pace, I don't know. What I do know is that this is not a hype, because artificial intelligence has been developing basically from the 1930s onwards, and each time we're getting to a higher level, and each time we're seeing more and more advanced technology being used. Now the real question here is, how can we shorten the time from actually new research to something that is deployed in an operational setting? So how can we shorten the horizontal axis in this curve? And if we look at what is happening right now, then we see there's so much brilliant machine learning solutions developed all over the place that are being shared by others in GitHub and are being picked up, but it still stays in the research environment. One thing I should have mentioned in this last cycle, that the acceleration in this cycle is really fueled by the open source ness of the solutions, the libraries that are that we use for machine learning. Say Keras, TensorFlow, Scikit-learn, PyTorch, these are all open source libraries, and that really has helped the acceleration. And if we look at our own industry, the EMP industry, then we see that the uptake is not as fast as in other industries. And many years ago, I wrote a small piece about this. I called it "No More Innovation at the Snail's Page." It was published in 50 Things You Should Know About Geophysics, publication by Hallam Bianco. And basically I argued that we think we are very forward-looking and advanced in our technologies, and we're innovators. But really, if we compare what we are doing with the rest of the industries, then we are a bit of a conservative bunch, and we're not really as forward-looking as others, or at least our uptake is slower than what we see in other industries. And I think one of the reasons is because we are very protective about our data and our knowledge, and we are not in the same sharing mood that we see in data sciences and in machine learning. And so we could learn something from the data analytics community in that respect. Now, where I see the real acceleration happening is when you have pre-trained models that can be reused on other problems, similar problems with other data sets. And yeah, that means that we need to create more of these pre-trained models, and that we have to release them. The creation is often the difficult part. That is where you do your experimentation. You need huge data sets, or you need to model data in order to create these models. But once you have a pre-trained model, then that is really the thing that captures the knowledge, the information, and that could be reused. So rather than sharing research code, as we see now happening all over the place, you can go onto GitHub and you can download a fantastic new technology, but it's very difficult to reuse because it's written as research code, and that means it is very difficult for others to understand what is happening, and to apply this in an actual operational setting is almost not doable. But if you would have a pre-trained model, then that is completely different. And what we need to do in our setting is that we have to give these operational geoscientists more of these pre-trained models, because that will decrease the time, the effort, and the costs. It will make their work faster, and will also make it more accurate. So we need a system where we can create these new models, and we also need a system where we can apply these pre-trained models to other data sets. So what have we done in OpenTect to actually make this happen? When we started developing OpenTect machine learning, we developed it for 3 types of geoscientists. The operational geoscientists, who are the ones who are always strapped for time. We want to give them pre-trained models that they can reuse on their own data sets. And then we built the same system for experimental geoscientists, who could use the system, which consists of the OpenTect part, which is the seismic interpretation environment, and the Python side, which is the research code side, where you can actually apply these machine learning models and build them. These experimental geoscientists can use the OpenTect environment to create new workflows, new training sets, use the models that have been released on the Python side, and train these models. And then these trained models can also be reapplied by these operational geoscientists on other data sets. And then we can have the researchers, and these researchers, they can create their own new models within the OpenTect machine learning system, because OpenTect machine learning system is the only system that is a hybrid system. It has a user interface as well as programming options. This is the user interface side of the system. So we have workflows for clustering, classification, and regression of well data only, of seismic data only, or of the combination of seismic and wells. And then we have this library of pre-trained models. And that is where we really want to create more and more of these pre-trained models in order to give these operational geoscientists more models that they can use. And then they only have to pick the right one, do some thorough testing like blind test in order to see whether the model is valid on their application, and then they can use it. Now this is the machine learning development environment, so that is in Python, and we have developed 2 Python packages which are also released in GitHub, on GitHub, so everybody can get to use it. It's ODPy, which are tools for getting access to the OpenTect data, generic tools, and then we have DGBPy, which are machine learning specific tools with wrappers for Keras, Scikit-learn, and PyTorch. Now we already released some pre-trained models with the software, and here we see a few examples. On the left we see the application of a pre-trained model that predicts faults from the seismic, and we also have released models for interpolating data, missing traces, but also for increasing the number of traces, so decreasing the bin size, super sampling if you like. Where I see potential for more pre-trained models is on the well side, predicting missing logs. I think it would be fantastic for many QI projects if we would have more shear sonic logs, and if we have models that can predict shear sonic logs from other logs, then this would really help the QI work that we are doing. Now, what the user who is going, the operational geoscientist who is going to use these models should always realize is that these models might be applicable sometimes worldwide, but sometimes they might just be applicable for a certain basin, or maybe even for just one formation. So that means that we will have in the future a huge set of models that can be reused for a specific application. Maybe models that are just applicable for the Road Ligand or just for the North Sea, and some others might be applicable worldwide. So I see potential for well data type of applications. I see a lot of potential for seismic interpretation, models that can predict horizons, for instance. If we look at a particular basin, then in every basin there are maybe 5 to 10 horizons that are always mapped. And if you have already mapped these on other data sets, then a model should be able to capture that information, that knowledge, so that you get a trained model to reapply this on new data sets. So you get already a very quick look set of horizons if you apply such models. The same holds for faults, maybe acoustic elastic impedance type of predictions, RGT predictions, and objects like salt, chimneys, things that also have a certain characteristics and can be extracted from the seismic and reapplied, because the characteristics are often the same across different seismic data sets. I also see a lot of potential for processing, seismic processing. We have not implemented the pre-stack loop in OpenTect yet. We do support pre-stack data, but in the machine learning plugin, we should also be offering pre-stack information to a machine learning model so that you can do things with it. And if we do this, then I see a lot of potential for pre-trained models that can do, for instance, first break picking, picking velocities, maybe denoising filters, and so on. And then finally, there will also be models in the future that can do things directly with production data. So let's have a look at how we are stimulating this creation of the library of pre-trained models. So let's look at our implementation. We launched an OpendTect machine learning development community on Discord. And at the moment we have more than 270 users on this Discord community, and we are encouraging these users to start developing inside the OpendTect machine learning environment. So to do their programming inside the our machine learning environment. They start to use the ODPy and DGPy packages. This is not necessary, as I will show in the next few slides, because you can also work in your own environment. But eventually what we want to do, of course, is we want to get access to these trained and untrained models so that we can share these with our users in OpendTect. So the sharing of models can either be completely free under an open source type of license, Creative Commons type of agreement, or it could be done under commercial terms. And then we let you decide if you think you have a fantastic new model that you want to share with the rest of the community. Then it's up to you what pricing you will set on this model. But from a business perspective, and I think this is really where large companies should be interested in our solution, is that a lot of research at the moment is going on in big companies, and this research is still staying inside the company as research code. And if these applications become successful, it means that the researchers start to do service work with their research code. And what we offer in OpendTect is that you create your own proprietary library with these models that can be reapplied by these operational geoscientists. So by making these models that you have developed available only within the company, you could train these models on your own data. You could also create your own models, which are probably superior to the rest of the world, but you can then actually use it in an operational setting. And that is the big plus that we are offering here. So to make that happen, we implemented in the last release a facility, a utility to upload your own pre-trained models. And we have a new button in our control center with pre-trained models where you can see that we are already releasing some of these models with the software. And some other models, they are available to you on our cloud portal, where we have, and these are indicated by the download status icon. So you have to download these models first, and then you can use them in OpendTect. And that is because some of these models are pretty large. And if the library is growing, then we don't want you to download all these models if you don't need them, because that would slow down the installation of new updates of OpendTect. So you can see the library, but you can also see information on each model. If you press this pre-trained model information button, then you will see what kind of model is this, what is the input, what is the output, what has it been trained on. Is there more information, like is there a paper on it or a video or examples that I can see? And if you decide that this model could be applicable for me, then you download it and you can start using it. Models can be imported from Keras TensorFlow models, from PyTorch, and from Scikit-learn. So these are the major libraries used in the industry. And if you go to GitHub and you search for models, then you will literally find hundreds of these, thousands of these models, which could very well be useful in your setting. These could be trained. This could also be untrained models. If you want to have the most advanced model, pick it up from GitHub, import it, and you can start using it in OpendTect. And that concludes this webinar. I'm open to questions. So thank you very much for your attention.